So in this chapter, we're going to really be focused on attribute sampling. And so attribute sampling is what you use for test of controls. So moving on to attribute sampling, because this is what we use for test of controls. This is when we're looking at a particular portion of the population that possesses a certain characteristic or certain attribute. For example, if you're doing a test of control over this control that all the purchases of a company that are over $500 have to have 2 signatures, then the attribute you're testing is the 2 signatures, right? Okay, we have all these purchases over 500, and I'm looking for the attribute of the 2 signatures. So there's this portion of the population, I'm expecting it to have this one specific characteristic. And these are kind of our steps that we want to follow when doing a test of control, right? We plan it, we perform it, we evaluate it, and whatever you do, do not forget to document it. Okay, so starting off with the planning. So first off, in your plan, you have to determine the objective of your test. All right, so the objective of any test of control typically is to figure out if a given control is operating effectively. Then define the population characteristics. Okay, so first off, define your sampling population. So all the items that possess whatever the characteristic that you're trying to test, that's going to be your sampling population. So our example where this control, where all purchases over 500 have 2 independent signatures, our population that we're looking at is going to be all purchases over 500, right? Because I want to look at those, grab a sample of them, and then see, do they have those 2 signatures? All right, next step is define the sampling unit. So each sampling unit is one item in the population. And I actually managed to write it out on this slide. So each check or purchase order over 500 would be a sampling unit. Then you have to define the control deviation conditions. Right? So you have to decide upfront before you start testing, because once you start testing, you're going to be biased by what you've seen. So upfront, you need to decide, what does a control failure look like and what does a pass look like? I have down here that you have to kind of decide how strictly you want to adhere to a control. Do you care kind of about the spirit of the control or the letter of the control? All right. So the spirit, for example, of that $500 purchases having 2 signatures, the spirit of that control is that all the purchases over X size, right, have to be properly authorized. So it is very much an authorization control, but the letter of the control is saying 2 signatures. And you'll see different kind of schools of thought on this. In one of my experiences, it was actually on my public client where KPMG was the internal auditor. So they had kind of outsourced their internal audit function to KPMG. And this one guy, Tom, was the manager. He was extremely, extremely strict with control testing and them following the letter of the law. And I don't mean like 2 signatures, because I think that's pretty reasonable, right? You kind of expect if they write 2 signatures in the control language that they have 2 signatures. I don't think that's unreasonable. But he would say, all right, this control says 1 signature has to be in black ink and 1 signature has to be in blue ink, and they have to be dated and they have to be in cursive. And this person used all caps print, and so this control fails, right? Or they both use the black ink instead of one black ink, one blue ink. So this control fails. So he basically would be failing controls left and right for reasons that were honestly quite petty and silly. And, stepping back and looking at the big picture, we, as the external auditor, really felt like the controls were working and doing what they were meant to do. The spirit of the control was working as intended. And really, he wouldn't have failed it if the control language wasn't so specific. So that's what it means by defining these control deviation conditions. Okay, so next up is determine the sample size using the following inputs. All right, so we talked about these inputs already. So first off, we figure out what confidence level we want to use. And typically in sampling for TOC, we're going with a 90 or 95% confidence level. The 99%, because I know earlier we were looking at tables that were showing 90, 95%, 99. 99 usually would lead to a really improbably large sample sizes for test of control, or I should say inefficiently large. So typically you would go for the 90 or the 95. Then your tolerable deviation rate, right? This is how often you're willing for this control to fail, still call it effective. So depending on how important a control is, if it's really important, maybe I want my tolerable deviation rate to be a bit lower. If it's less important, I'm willing to go higher. And your expected deviation rate. All right, and again, this is generally based on what the historical deviation rate has been in prior years. The expected deviation rate has a direct relationship with sample size, meaning the bigger the expected rate of error gets, the bigger sample size gets. All right, this is a fun table that summarizes all the factors that impact sample size for test of controls and how they impact sample size. So confidence level has the direct relationship, meaning the more confident you are that you are getting a representative sample, the bigger your sample size needs to be. And we just talked about the fact that the expected deviation rate has a direct relationship. So the higher it's been in the past, the bigger your sample size would need to be. And the tolerable deviation rate has the inverse impact on sample size. So if I'm willing to accept less errors to call the control effective, then I would need a larger sample size. But if I'm willing to accept a higher rate of error and still call the control effective, then I'd be able to decrease my sample size. Also think about these two and how this guy has a direct relationship and this guy has the inverse relationship. You can think about that concept of precision that we talked about on the earlier slide and how it's essentially the difference between the tolerable error rate and the expected error rate. And the larger this difference is, the smaller sample size you can have. And the smaller this difference is, the larger sample size you're going to have. Another thing to keep in mind here, which isn't on another slide, but it's really important, is your expected error rate is never going to exceed your tolerable error rate, because that would essentially be like saying I am going into this test of control expecting the control to fail more than I am willing to tolerate. If that's the case, you would never test the control. You would set control risk to max and go ahead and do your substantive testing, take the substantive approach. So you'll never see an expected error rate larger than your tolerable error rate. Population size doesn't normally impact sample size for test of controls. It does impact sample size when population size is small, relatively small, meaning less than 500 items. But most of the time when we're doing test of control, we're testing daily controls or controls that happen multiple times a day. So our sample size is pretty big tends to be large, and so that's why it doesn't impact sample size. All right, here's a question. If all other factors specified in a sampling plan remain constant, changing sampling risk from 5% to 10% will cause required sample size too. I'll let you pause. All right, so, first of all, if I'm changing sampling risk from 5% to 10%, sampling risk is not on this chart, right? The complement of sampling risk, which is confidence level, is so basically changing sampling risk from 5 to 10% is the same thing as changing your confidence level from 95 to 90%. And so we know if I'm decreasing my confidence level, that's basically like saying, okay, if I'm willing to become less confident that I'm drawing a representative sample, then the sample size will decrease. So then you pick the items from the population that you want to sample. Okay? So you can do random sample selection, which when we have random selection here, it means truly random, meaning there's got to be some kind of computer program, random number generator, helping you come up with the random selection, right? If you're just kind of scrolling down a list and picking things, that's not really random. That's actually haphazard because you're still kind of intrinsically using your judgment and your biases, right? You have a bias of how long you like to scroll before your finger gets tired, right? Maybe you scroll 2 times every time, whereas someone else scrolls 3 times. So to be truly random, it's got to be a computer. Right. Systematic selection is when the auditor determines sampling interval by first dividing the population by sample size. All right, so population divided by sample size. So let's say I have 1,000 items in the population and I have a sample size of 100. So then my sampling interval is going to be 10. The starting number is randomly selected in the first interval, and every nth item is selected thereafter. So the part that says the starting number is randomly selected in the first interval, this is the first interval, all right? So I randomly will select a number between 1 and 10. So let's say I select the number 3. The third item will be the first item that I test, right? When it says every nth item is selected thereafter, what that means is you add the sampling interval to the first item you randomly selected to get the next item. So it's this plus the sampling interval of 10. I get item 13. Okay, so that's going to be my second item for testing. Then I add the sampling interval again, I get item 23. This is going to be my third item for testing, and so on and so forth. Then you're going to perform your auditing procedures. So we have this example here where you have a sales invoice. The control is that a sales invoice shouldn't be prepared unless there's a related shipping document. So your population is going to be all the sales invoices, and then you pull a sample of sales invoices, and for each one of those, you should be able to find a related shipping document that supports the sales invoice. If the shipping document is present, this will show me the control is working properly. But if the shipping document is not present, that will show me there's a problem with this control. A deviation exists. If I find voided documents or documents that are otherwise unused or NA, then there's nothing wrong with that. So what that means is we said I'm pulling the third item, the 13th item, the 23rd item, right? So if I go through and I look at item 13 and they pull invoice 13 for me, and the invoice is voided out, meaning it was never used, then that's actually fine. There's not a problem with that. What that does mean, though, is I need to replace the item with a new sample item. So the reason for this is voided documents or unused NA documents, those are a normal course of business. Right? They do occur in the normal course of business. Obviously, if we find like half the items we pulled are voided, there's something weird going on. But you do occasionally come across one that just wasn't used or was accidentally skipped for whatever reason. They do occasionally pop up. So if we can't examine the sample item, we might try to use alternative procedures to test the control, but if none of that works out, we just can't find the item, then that sample item counts as a deviation, okay? It counts as an error. When I say inability to examine an item, this includes, let's say you pull the sample, 313, 23, 33, and your client contact comes to you and they're like, oh gee, we have all the others, but items 13 and 23, they're in the very back of the warehouse, and we're going to have to move like 500,000 pounds of boxes to get the paperwork for you, and it's going to take the forklift operator like 8 hours to move all the boxes, and can you just pick other items? Okay, then we would say, well, no, because if we can't examine them, basically we have to count them as a failure, right? It's no better than the item not existing or being thrown away or whatever. So if we can't examine it, we kind of assume it's wrong and assume it's an error for purposes of test of control. And in terms of stopping the test before completion, right, this might happen if we did find large numbers of errors early on in a test of control. So let's say I'm doing a test and my sample size is 50 and I have a tolerable deviation rate of 10%. I go ahead and I test the first 10 items and 8 are errors. Basically, at this point, there is no point or reason to test the last 40 because I already know I have, just in the first 10 items alone, I have an 80% error rate. And not only that, but I'm already well over the 10% error rate, even if the other 40 are perfect, which odds are they aren't going to be. So at this point, you are allowed to stop the test of control and just document that the control failed. The next step is to calculate the sample deviation rate and the upper deviation rate. And the purpose of calculating these is you want to compare them to your tolerable deviation rate. All right, so your sample deviation rate is very easy to calculate. It is just the number of deviations divided by your sample size, right? So it didn't work twice and your sample size was 50, then your deviation rate is 4%. Upper deviation rate is something slightly more complicated, which we will talk about how to calculate that in a minute. We get to use these fun tables to calculate it. And it basically represents the sum of the sample deviation rate, 4%, plus this allowance for sampling risk, right? So basically an allowance for the fact that we might have pulled a sample that wasn't representative. And this will give us a upper deviation rate, which represents basically the worst case scenario. And that's what we're going to compare to our tolerable deviation rate, right? We compare our tolerable rate to the worst case scenario for this control. And if worst case scenario for how often this control goes wrong is less than the tolerable, then we're okay, right? Because basically things are going wrong at a lower rate than what we've decided we can tolerate, so things are good. If your upper deviation rate is greater than your tolerable error rate, then we're not happy, right? And then the control fails. And this table just kind of summarizes everything. And it kind of goes back to that earlier slide we were looking at. So it shows all the potential decisions you can make. So we have the true state of the internal control. It's either reliable or not reliable. And then remember that the true state, we said, is unobservable unless you're testing 100% of the items in the population. Then we have what the auditor thinks the control is, right? Just the auditor think the control is reliable or not based on the sample that they pulled. So either they're going to conclude that the control supports the planned level of control risk, in other words, it's reliable, or doesn't support what they thought control risk was, right? In other words, not reliable. So if the sample tells the auditor matches up with the true state, then they reach the correct decision, right? Reliable matches reliable. If non-reliable matches non-reliable, then we're correct decision. If not, then we have the type 1 and the type 2 error, which we talked about earlier.